Welcome students. Yesterday we discussed about the temperature scale, Fahrenheit scale, Celsius scale, and how they convert from one scale to another scale. Okay, and now we discuss the types of thermometers. So the today's point is types of thermometers or types of thermometer. Now we know the things. As we heated the material, the properties of the material changes. In last lecture we discussed the formula. Temperature T is equal to 100 into the physical property, the value of the physical property P at a given temperature minus the physical property at the temperature T1, say the ice temperature, divided by the physical property of the temperature at steam and the physical property again same at the ice level. Okay, means here P is the generalized word for the change in physical properties. So in case of the mercury, we count the length 25 mm. Similarly, sometime in some materials the volume will be changes, in some material pressure will be changes, particularly in the gases. In some material resistance also changes, or in some material colors also changes. According to that changes, different changes, we made a thermometers. So from this, the first thermometer, say the types of gaseous thermometer. Gaseous thermometer means a thermometer in which the substance are in the gas form. Okay, so the gaseous substance, like any type of the gases, thermometers, gaseous thermometers. Like here two conditions are there in gaseous thermometer. One, if pressure P is constant, volume V will be changed with temperature. So means as we give the heat, its temperature increases, means the volume of that material increases. And find out the change, means here instead of P, for particularly that gaseous thermometer, I use temperature T is equal to 100 into the volume at a given temperature, volume of a gas which used to make a thermometer, minus the volume of that gas at a freezing point, or say the ice point V1, and similarly the volume of gas at a steam point V2 minus again V1. Okay, this is formula same, where the volume changes. All the thermometric parameters, we say there are thermometric changes, the value of that put here, and we can easily find out. Suppose in the same case, instead of P, if we put volume is constant, then pressure will be changes. Pressure will be changes with temperature T. With temperature, then the formula will be convert just T is equal to 100. Now instead of V, here the pressure P at a given temperature minus pressure P at a ice point divided by the pressure P at a steam point P2 minus again the same term. By calculating these terms, we can find out the temperature. These all thermometers are very sensitive, very accurate, because the small change in the temperature, the sudden change occur in their volume or pressure. That's why we find out the more accurate reading. But the problem is the instruments are bulky instruments, so they are not easy to handle. It is difficult to portably handle. Okay, so what we make another types of the thermometers. Second one, say first types gaseous thermometer. Now here is it, liquid thermometer, or a second one, liquid in glass tube. Liquid in glass tube. In such a type of thermometer, we made a very fine capillary tube having a very small bore, and we pour some liquid material which is storage here, and as the temperature goes on increasing, the length of the liquid level is changes. Now means here the thermal change is length. So we find out the length, change in length, and we can calculate the temperature of the system by using such thermometers. In this case, we basically use two types of, again, by using mercury, and the second one is by using alcohol. Why you take this? Because the mercury's melting point, the mercury's boiling point and their freezing point are very wide range, means approximately 49 minus degree centigrade. This is the freezing point of mercury. Okay, and boiling is approximately 150. It's not accurate 150, but 150 degree. So we obtain too much wide range to calculate the temperature. Similarly, in case of alcohol's freezing temperature is approximately some minus 11 degrees Celsius, and the boiling is something 77 degrees Celsius. Okay, so we can easily find out. Sorry, 1 minute. The minus term is, the freezing point is something very low. The freezing point of the mercury minus 150, not a minus 150 degree. It's too much small. And the boiling point is 75 or 77 approximately, to 75 according to their purity. And the formula is same obtained, T is equal to 100. Now here the change is occurring length, so that's why I take the L at a given temperature minus L at a freezing point divided by length of the material at the steam point minus L at the again freezing point. Formula is same, but according to the change we just modify the term. If the pressure it changes, we take the P. If the volume it changes, we take the V. whether the length it changes, we take the L, and according to that we made some types. Now the next one, the third types of the thermometer is platinum resistance thermometer. Platinum resistance thermometer. In this case, the electric resistance of the material changes as we heat it, or as the temperature is increases, the electric resistance of the material changes, and the formula is simply here, the temperature T is equal to RT minus R1 divided by R2 minus again R1. The same notations are: RT is the resistance of the material at a given temperature, R1 is the resistance of the material at the freezing point, R2 is the resistance of the material, here particularly the platinum, at a steam point, and R1 is the same again, the resistance at the freezing point. And by using this we can calculate the temperature of a system, and we make some thermometers like this. Here one more plus point is there, they are more accurate and having the high range thermometers, and again they are also the very bulky, so it is not easy to handle as compared to the previous one, liquid in the glass thermometer. Okay, some again, next one is also the chromatic thermometers. In chromatic thermometers, the substance which is used in that thermometer, the color of that substance changes according to the temperatures. Zinc oxide appear white at the room temperature, but as the temperature is increases, its color become yellow, means the apparent color are changes, and by finding out the frequency of that particular reflecting lights or colors, we can calculate the temperature again also. Next one is the thermistor thermometer. In thermistor thermometer, a material used is semiconductor. The detail about the semiconductor we will discuss in the semiconductor chapter, but here remember that the resistance of the semiconductor is reduces as the temperature increases, and find out this change means they have the negative temperature coefficient. Okay, means as the temperature increases, its resistance reduces. Okay, and finding this change of the resistance, we can calculate the temperature of a system by using the same formula. Okay, and another one is type here, the thermocouple. Thermocouple means two different substances are merged with each other. It may be the alloy or a pure material of any metal, like this, suppose the copper and some aluminum. Are they joined? Means they perform a couple, and when they heat it, the EMF are produced across the 2 points of that material, because they produce the EMF, electromotive force, across these 2 points, and the current will able to flow through it, and by measuring the quantity of current, it is a very small amount but sufficient to find out the temperature. And this is the basic principle of the thermocouples. Okay, these all types of the thermometers used based on the thermometric change in the physical quantities. Whether the length it changes, we use this liquid in the glass. Whether the volume it changes, pressure it changes, we use the gas thermometers. Whether the resistance it changes, we use the platinum resistance thermometer. And whether the color it changes, chromatic. Such type of the thermometers are used in day-to-day life to measure the temperatures. Okay, now the important point of discussion is absolute zero temperature. Okay, what is meant by the absolute zero temperature? Okay, now I will stop here, and in the next lecture we will continue the absolute zero temperature and Kelvin scale. Okay, thanking to all of you. Thank you very much.